Okay, so shortish video, I think, on sketching exponential functions. I wouldn't normally do this, so we're actually going to look at sort of plotting a couple, but obviously normally A-level maths we sketch, but just to show you what's happening. So when x is minus 2, 2 to the power of minus 2, 1 over 2 squared is a quarter. When x is minus 1, 1 over 2 to the 1 is a half. When x is 0, 2 to the power 0 is 1, x is 1, we get 2, and x is 2, we get 4. When x is 3, we'd get 8, then 16, then 32. So as x gets bigger, these are doubling up. So they get big really, really, really quickly. I'll give you, I'll give you a link to a little YouTube clip about doubling up and how big things get, because it's quite nice to see. So as x gets big, we're growing exponentially, so getting big quickly, like so. And then, sorry, left-handedness. And then as x goes negative, we'll be doing a half, then a quarter, then an eighth, then a 16th, then a 32th. And so we're going down towards 0. So you get this exponential shape. And the x-axis is an asymptote to the curve. So that's sort of roughly what y equals 2 to the x looks like. I'm not sure it's my best exponential shape ever. If instead I wanted to do y equals 3 to the x, so this is going through here at 1, then obviously you'd be timesing by 3 each time, so that's going to get big even quicker. And then you'll be going a third, a ninth, 27th, 1 over 81. And so it will come down on the x-axis even quicker. So y equals 3 to the x would look comparatively something like that. So it's going to be steeper. So just to sort of emphasise the difference. Obviously, if we had y equals 1 to the x, we'd get a straight line. So you can kind of think of these as getting steeper, 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 shallower, shallower, shallower as this number approaches 1. Right, y equals a half to the power of x. So I could rewrite this using indices. So you can split a power over a fraction. 1 to any power is 1. And so that is equal to 2 to the power of minus x. So they're exactly the same thing. And 2 to the power of minus x does this. So minus minus 2 is 4. It's 2 and 2 squared is 4. Sorry. And then 2, and then 1, and then a half, and then a quarter, and so on. So it's the mirror image of the one above, and so that causes a reflection in the y-axis, which you should know from your transformations. This is like having f of minus x if this one is f of x, so that reflects you in the y-axis. And so the sketch of y equals a half to the power of x or 2 to the minus x is, I won't bother doing it to scale so much this time, it's going to come down like this, like so, and through 1. So the two things to glean from there, first of all, get a cleaner board. So if you're sketching y equals a to the power of x, and a is bigger than 1, so this is quite important, this is bigger than 1, then you will have this general shape. A to the power 0 is always 1, So they're always going to pass through 1 on the y-axis. And then the x-axis is an asymptote. So the really important things here is asymptote. So asymptote of y equals 0, exponential shape, and it passes through 1 on the y-axis because a to the power 0 is 1. And if it's growing like this, this is called exponential growth. So things like populations can grow exponentially until something comes along to level them off. If, on the other hand, you've got y equals a to the x, and a is between 0 and 1, obviously if a is 1, we've just got a straight line, and if a is 0, we've just got y equals 0, which is a straight line. Then this is going to give you exponential decay. So this one, should move that over a little bit. Oh, sorry. Right, move over to there. Right, so if I do down, down, it's the reflection of this one in the y-axis. So it comes down like so. So this still has an asymptote at y equals 0. Passes through 1 on the y-axis, and this is known as exponential decay. The other way this could look, which sort of described over leaf, is that y could equal a to the minus x. So it could be in that form where a is bigger than 1, and that will also give you exponential decay. It's just written in a different way. I've never seen one between 0 and 1 with a negative on it, but that would give you growth. So 2 ways of looking at that. Hope that's all right. We need to move them around with some transformations. I'll do that on the next clip because of my phone memory. Okay.